Hello students, welcome to my YouTube channel Concept Tech 2018. I am Dr. Sunanda Manke and this is the series on online electronics laboratory, and in this part we'll discuss the lab exercises on regulators. The experiment is done on positive fixed regulator LM78XX series. It's a 3-terminal IC regulator. As you can observe in the figure, it is available in these packages. Here XX denotes the output voltage value, like we have 5, 6, 8, 9, 12, 15, 18, 24. So if it is 7805, then the regulator's output voltage is constant to 5 volts. If it is 7824, then output voltage is constant and it is 24 volts. This is the internal diagram of this regulator circuit, and in this circuit the pass transistor which is used, it can handle 1 amperes of load current. The output voltage is given by this formula. These dashes on the resistors indicate that these resistors are inside the IC, and these resistors are used to give feedback to the input side so that the voltage can be regulated. The features of this regulator is the thermal shutdown and current limiting. Thermal shutdown means whenever the temperature exceeds a certain limit in this regulator, the regulator automatically shuts down, and current limiting is provided to protect the regulator from short circuits and high currents. This regulator offers a very high ripple rejection. It is in the range of 80 dBs. This is a 3-pin IC regulator 7809. Now we'll observe the output on the multimeter, shifting the multimeter close to the power supply so that we can observe both the voltages. We are changing the input now, increasing the input from 1 volts and observing the output. Output will change with input up to 9 volts. After we reach to 9 volts, output will become constant as it is a voltage regulator IC, and you can see output is constant to 8.2. For change in the input 16 volts, 17 volts, it is changing, it is going up to 8.5, and when you reduce it, it comes down. This is 7805 IC, it gives 5 volts regulated output. We'll change the input supply and observe the output on the multimeter. We are changing it 3.5, 3.9, 4, 4.9, and now after 5 volts output is constant to 5.28. We are increasing the input voltage 9.4, 10, 11, 12, and you can observe on the multimeter output is constant 17.5, 19, and in output is constant to 5.3 volts. Now we are reducing up to 5 volts, it gives you 5, and as soon you reduce it to 4, the output becomes low. Now we are doing experiment with 7812. It's a 12 volt IC. So output should be constant at 12 volts when we increase the input supply. We have increased it up to 12 volts and it gives us 12.5, 12.6 at the output. Now we go on increasing the voltage 20, 24, 25. Output is constant at 12.6. We are reducing up to 12. It gives you 12 volts. As soon you go down, the output becomes low. We have observed in this experiment that LM78XX regulator produces constant output voltage, and the output voltage is independent of input voltage variations. We have taken the IC 7805, 09 and 12, that is we observed 3 regulator ICs. 7805 gave us 5 volts output, 7809 produced 9 volts constant output, and 7812 produces 12 volts constant output. And we have observed that output voltage is constant for change in the input voltage, but we need to keep input voltage higher than the rated output voltage for regulation. That is for 7805, when the input voltage crosses 5 volts, then only we get 5 volts at the output. Up to 5 volts, the increase in the input is directly reflected at the output side. That is when input is 1 volts, output is 1 volts, input is 2 volts, output is 2 volts, and as soon input goes above 5 volts, 5, 6, 7, 8, the output remains constant at 5 volts. I hope you have understood how the voltage regulators work. Thank you.